Adjunct Professor Moran, Microeconomics 112. We're discussing externalities, or when a benefit or a cost accrues to a third party to a transaction, not the buyer or seller. And sometimes there are positive things that occur to someone that's not in a transaction, sometimes negative. We'll discuss positive externalities first. Externalities are also called spillovers because the benefit or cost is spilling over from the market. So positive externality is a benefit that accrues to someone other than the buyer. So this results in an underallocation because the buyer doesn't need to purchase the product to get the benefit. And these people who don't buy the product but get the benefit are known as free riders. This causes the demand curve to shift to the left of the optimal amount. Correcting for a positive externality or spillover, there are two choices. Either you can give a subsidy to the consumer to encourage them to buy it, or you can give, which would lower their cost, or you could give the subsidy to the producer, which lowers their cost and would shift the supply curve to the right. Okay. Either way, you want to increase the quantity exchanged in the market. The subsidy is going to be the vertical distance between the two lines. Okay, so if this is the optimal amount, you can either get this reduced amount either by shifting supply or shifting demand. So let's say it's a demand issue. Not enough people are getting inoculated, for example. Because demand has shifted to the left, the optimal quantity is now not the equilibrium, and we have this quantity under allocation. So this amount is the under allocation from Q sub 0 to Q sub U. Okay, so if we're at this point, D2 and D1, and you want to correct the under allocation to optimal, you would give consumers a subsidy equal to the vertical distance between these lines, and since they're parallel, you can measure it any place along this line. So if this is 400 and 500, you give the consumer $100 voucher, and that would lower the price to the consumer, and it would increase the demand. Okay. Notice that this would cause an increase in the price of the good, theoretically, P1 to P2, but it would correct the under allocation. Or you could give the subsidy to the producer, so here's the quantity under allocated, quantity optimal. And if you give the subsidy to the producer, you reduce the producer's costs and shift the supply curve to the right, which corrects for the under allocation. And the subsidy has to be the vertical distance again, whatever this dollar amount is. Now, if this will take us from P1 to P2, which lowers the price. Theoretically, the producer should pass along the subsidy to consumers in the form of lower prices, which is debatable in reality whether that would happen. So these are two different ways of correcting for an underallocation, but with theoretical different consequences. One results in a lower price by giving the subsidy to the producer. One results in a higher price giving the subsidy to the consumer. Okay, negative externalities result in an overallocation of goods and services to society because the costs of cleaning pollution are not in the transaction. And so anything that lowers the business costs shifts the curve to the right. So the government's role is to put the cost back into the transaction and cause the supply curve to shift to the left, back to the optimal amount. Negative externalities result in overallocations to the market as the cost of not polluting is not included in the producer's cost. Okay. Now, there are several ways of fixing pollution, and a popular one today is market-based solutions. Now, many environmentalists don't like market-based solutions because it's seen as by some environmentalists as a way around strict restrictions on limits on pollution. And there can be some misclassification of expenses which would allow businesses to pollute more than they should, as was written in the New York Times a few years ago. So in this example, if this is the socially optimal amount that the government wants pollution to be limited to, there would be a market for pollution rights. a company that is more efficient and not polluting at their limit could sell this amount of pollution to a company that isn't efficient, perhaps out here, and then that would keep society in the limit, and it would reward efficient producers and provide an incentive to inefficient producers to update their equipment and become more efficient. That's the market-based solution. In addition, over time, as the economy grows, perhaps so does the demand for pollution rights, right? More industries, more pollution. And so if this is 2019, in 2020, the demand would shift and the value of the pollution rights would be greater, providing an even greater incentive to modernize equipment and produce less. Notice that if there was no market-based solution, the supply of pollution, if the price of pollution was zero, if it was unregulated, then in 2019, instead of being limited at 500, businesses would want to pollute 750 quantity of pollution. And in 2020, if there was no incentive to limit pollution, pollution would grow to 1,000. But society will be limited to 500, and so there's an economic incentive not to pollute, a reward and a penalty. Now, other ways of fixing pollution include lawsuits. This would be similar also, the graph would be similar if the government just compelled businesses to limit their pollution to a certain amount, and it would drive up their costs. So lawsuits are an after-the-fact kind of solution to a problem. Someone's been harmed and they're suing. Whereas if you set a limit and compel the businesses to buy equipment to limit pollution in the first place, you avoid some of the problems. For example, in the 70s, when the government wanted automobiles to be outfitted with catalytic converters to reduce pollution, the auto companies complained that it would increase their costs and would cut down on the amount of sales. It would increase the cost like something like $500 on a car that costs thousands of dollars. And it was a very effective program in cleaning up pollution. There were cities like Pittsburgh and Los Angeles where the smog was trapped by mountains. And on a bad day, you couldn't see the cities from the top of the mountains. So, you can achieve results by either regulating businesses or through a lawsuit. Okay, lawsuits result in awards paid by producers of negative externalities to those who were harmed. It results in increased costs to the business, and it will result, since the costs are higher, the supply curve will shift to the left, S1 to S2. Label it reduction to the overall allocation. Okay, so here is quantity unregulated, and here is quantity optimal, correcting for the pollution. So you're going to shift the supply curve to the left, and that will drive the cost of the product up. What happened to price? It increased. What happened to the labeled the amount of the lawsuit? Okay, it's a vertical distance. The award has to be this vertical distance to shift the supply curve that way. And so whether it's costs of new equipment or the cost of lawsuits, you're going to shift the curve that way and solve a negative externality. In our next video, we're going to talk about a different kind of market-based solution to externalities, negative externalities, called cost theorem.